Okay, now you see Tyler's stability number. Tyler's stability number Sn is equal to C by gamma Hc. To be frank, you see, I know students, they want to know, sir, what is the basis? You are writing some equation, Sn. You are trying to say it is Sn means Tyler stability number. And we have C. Yes, we know C. Cohesion. Gamma. Yes, we can understand what is gamma. Unit weight of soil. Hc. Then we can understand Hc also. Critical height. We know that. You see, the Hc, the term Hc is discussed in Tyler's, not only in Tyler's stability analysis. You might be recollect our days of discussion in lateral earth pressure, the depth up to which no support is required. You can recollect the depth up to which no support is required, also called critical height. So now Hc, you know what is meant by Hc critical height. Now you can ask me a question. So I am allowing you people to ask a question. The question is, how you got this equation? See, uh, I can able to tell you the way this equation is originated, the way the Tyler is developed. But it is out of our interest. The reason is this derivation you can found in stability analysis of infinite slopes. Stability analysis of infinite slopes. So infinite slopes is not in our syllabus. Our syllabus is only concentrating on finite slopes. Finite slopes. So our syllabus is mainly concentrating on finite slopes. So during analysis of infinite slopes, we will realize that during analysis of infinite slopes, we will realize that the way this equation is originated. Anyhow, no need to regret. Just think that this is a simple equation. So Tyler stability number Sn is equal to C by gamma Hc. Now someone can ask me, sir, what is factor of safety? Factor of safety is equal to Hc by H. Hc by H. So someone can ask me, sir, what is Hc? Critical height by original height. Original height of the embankment, of the slope, height of the slope, nothing wrong. If you write embankment, some people think that embankment is the only slope. Someone is coming and ask me, sir, why can't you say it is a cutting? That's why we are carefully writing about this H is height of the slope. Height of the slope. Now you see, I can write this above equation, Tyler stability number. Sn is equal to C by gamma Fc into H. Fc into H. Now what is factor of safety? Because you see, I can tell you one secret. Don't tell to anyone. So the secret is in all the entire chapter of slope stability analysis, what we are calculating. So please keep it as a secret. Factor of safety. Factor of safety of the given slope. Factor of safety of the given slope. The factor of safety of the given slope. F is equal to, can anyone tell me now? F is equal to, Fc is equal to, can anyone tell me now? C by gamma H into Sn. Gamma H into Sn. What is Sn? Sn is a Tyler's stability number. Strictly speaking, the Tyler stability number, it is available in the form of charts. So, but there is no culture. There, unfortunately, we don't have a culture of spreading sheets. What I say, giving sheets and code books in the subject of foundation engineering. Unfortunately, so that's why you don't worry. In the examination, they will provide Sn value. Okay, so because we don't have any habit of giving some design codes or code books in examination, especially in our subject foundation engineering. That's why, so you don't worry, they will give you Sn value that was picked from the Tyler's chart. Tyler stability charts. So SN value given to you, you don't worry. You need not worry about SN value. The questionnaire will give you SN value. He will give cohesion. He will give gamma, unit weight of the soil. So what he is expecting from you is determination of factor safety. He will give C, he will give gamma, he will give H, he will give SN. So what you have to calculate is factor safety. And being an engineer, you should ensure it should be more than 1. It should be factor safety should be more than 1. Then your slope is stable. And also we have more expectation. So I told you many times in the railways, because they are constructing so many embankments. The railway track itself is standing on embankment. That's why many times I'm trying to mention Indian Railways. So the reason is very simple, because we can found throughout railway track it is standing on embankments. So they're expecting more factor safety. I'm telling you, once you after the end of graduation, if you are entering into any job, they will ask you question: do you know what is factor safety? What is the minimum factor safety required for the slope stability? So you can say undoubtedly it should be minimum 1.4. So when you are appearing for the interview. So now what is C? Cohesion. So for your understanding, I will draw an embankment. This is C, this is phi, this is gamma, this is the height of the embankment. This is the height of the embankment. What is C? Cohesion. What is phi? Angle of internal friction. What is gamma? Unit weight. What is H? Height of the embankment. Height of the embankment. Nothing but you see height of the slope. Don't worry, I am going to show you height of the angle of slope, beta. Beta. Angle of slope, beta. Side slope. So this is an embankment. It is constructed with soil. The properties of the soil are given. C, phi, gamma. Height of the embankment is given. Now people asking you whether this slope is stable or not. So then calculate factor safety. What is the formula? Fc is equal to C by gamma H into Sn. Luckily, if you got more than 1, if you are getting answer more than 1.2, 1.3, 1.4, so we can see some happiness in our mind. We are ready to accept this particular slope is stable. Otherwise, what we will suggest? We will suggest some improvement techniques. If your slope is in struggle, if you want to improve factor safety, there are certain techniques that we are going to discuss in the today's class. How to improve this slope. See, it is not calculating factor safety and crying ourselves. Sometimes you see people say that, sir, I'm calculating factor safety. I'm not getting factor safety more than 1.4. Then what I will do? See, you are an engineer. You never think back. You never look back. So you will think, you will apply your mind. Being an engineer, civil engineer, you will think, we have certain techniques to improve this slope. There are certain techniques to improve factor safety more than 1.4 that we are going to discuss today. That is our last topic. So now our concentration, you see, we are going to calculate factor safety using Tyler stability number. This is also called Tyler stability charts. Tyler stability charts. So the Tyler stability charts gives SN value. Now I will ask a bunch of questions to you. What is SN? Can you tell me now? Say anyone can unmute and speak now. What is SN? SN means Tyler's stability number. So which is equal to C by gamma HC. See now, see, I can tell you a very interesting fact. Can I apply Tyler's stability analysis? So just listen carefully for pure cohesionless soil. Just listen carefully. Can I use Tyler stability analysis for pure sand? Pure sand. You please tell me what is going to be happen. What are the limitations of Tyler stability analysis? I'm going to tell you. You no doubt Tyler stability analysis you can use for determination of factor safety of a given slope, but it has its own limitation. Can anyone tell me? Can I use Tyler stability analysis for the pure cohesionless soil? That means pure sand. Can I use Tyler stability analysis for pure sand? Please tell me. Please tell me, or at least you respond in chat box. So please, all of you, listen what I am asking. It is very important. What I am asking to you students is, tell me now, can I use my theory? My theory means here Tyler stability theory for the benefit of analyzing pure sandy soils. Can I use yes or no? You please type in chat box if because many times you are not interested to speak probably. So because you may have some problems. But what I'm expecting from you people, what I'm expecting from you people, what I'm expecting from you people, please tell me, can I use styler stability theory for pure sandy soil? So, so can I use yes or no? Tell me, please, because we are thinking about time. Time is very important. As you know, the assignment 2 is already announced. So we are going to discuss bearing capacity of shallow foundations from the next class. From the next class. So assignment 2 is having syllabus bearing capacity of shallow foundations. Okay, get ready. So we are going to discuss about bearing capacity from next class. So that syllabus, that topic is there in your assignment too. So please, all of you, I received a great extent of support from you students. Please continue that support so that I can cover unit 3 and unit 4 also successfully. So without the support of the student, see the class is nothing. You see, without student, how can I imagine the class? Classes means student and teacher, students and teacher. Then only it is called not it is class. Otherwise, it is not a class. So class means we need active students. All my students should listen carefully, and they should get benefit of what we are teaching. So they must be the first beneficiary of our lecture. So that's why I never hesitate to ask question. Even I'm a reluctant to teach, but I never reluctant to ask question. Even sometimes I use it to teach the question, and even I'm giving the answer, because teaching is nothing but thought-provoking process. It is nothing but it is a thought-provoking process. It's not thought-killing process. Teaching is a platform that enables to student to learn. It is not just sitting. Now you open your mouth. So please tell me. So my question is very clear. Can I use Tyler stability chart for pure cohesionless soil? Now you please open your mouth. Don't be tight-lipped. So please tell me now. So please tell me. Hello? I'm not, see, I'm not going to blame anyone. వినబడుతుందని నేను చెప్పేది? Hello? Are you able to hear my question? So please don't waste time, because we need to discuss a numerical example also on Tyler stability number. So please tell me now. I cannot use, see, if you are not interested to speak also, I don't want to blame anyone, because I know what problem you people are facing. But I can tell you, వినబడుతుందండి at least, because I don't know whether my lecture is, hello, అందరికి వినబడుతుంది, then that's good, and that's enough for me also. So no problem. I won't. Yes. Thank you so much. I think it is what our friend is saying. Our friend is saying very interesting point. See, if C0, so Sn is going to be 0. So sir, that's why then it is meaningless. Once Tyler stability number is 0 means the entire analysis is going to be 0. So what our friend is saying, don't use Tyler stability analysis for pure cohesionless soil. A soil having a certain C value only you can use Tyler stability analysis. Many times in GATE examination, they are asking limitations. One of our student in our class is always, I have taken feedback from the students. So they told me, actually, they are given some instructions to instructor. So what instruction they have given? Sir, okay, you are doing well and good. You are teaching class. It is your duty, okay. But while you are teaching the class, you tell me limitations of that, whatever you are teaching. So there are certain limitations, no doubt. But Tyler stability number is quick test. No need to devise these slides. No need to draw the surface, failure surface. Within seconds, we are getting answer. That's the beauty of Tyler stability number. Why Tyler stability number is popular in the slope stability analysis of finite slopes? Because of its simplicity, because of its easiness in calculation of factor safety. It doesn't need any background. Even a person with minimum knowledge, he can handle Tyler stability number. Now the thing is, it cannot be used for pure cohesionless soil. That is one limitation. And you see, I can tell you one beautiful thing in this entire Tyler stability. You see, if unit weight is increasing, what will happen to factor safety? If unit weight is increasing, what will happen to factor safety? Tyler stability number మనకు చాలా విషయాలు చెప్తుంది. Tyler stability number is giving lot of information. As unit weight of the embankment is increasing, as the unit weight of the slope is increasing, the weight పెరిగితే ఏమవుతుంది? Weight పెరిగితే ఏమవుతుంది? Factor of safety తగ్గిపోతుంది. As the height of the slope is increasing, you see, I have 3-meter embankment. So what happened now? If my height of the embankment is increasing, what happened now? If the height of the embankment is increasing, factor of safety is reducing. So if cohesion is decreasing, let me tell you once again, if cohesion is decreasing, factor of safety is decreasing. If cohesion is increasing, factor of safety is increasing. So if the height of the slope is increasing, if you keep on increasing the height of the slope, your slope is in struggle. That's why the flat slopes are more stable than steep slopes. So I can tell you once again. So flat slopes are more stable than steep slopes. But the challenge is flat slopes. If you want to construct a flat slope, you have to invest more money because you need more earth. That's why now we people fell in love with geosynthetics. Geosynthetics can enable us to go for steep slopes without sacrificing the factor of safety. Now Sn, Sn is Tyler stability number, which is a function of angle of internal friction. A hidden portion I'm going to tell you. If Sn is less, your factor of safety is in struggle.